The IUCN Red List of Ecosystems is an emerging global standard for documenting the relative endangerment status of ecosystems. It serves as a complement to the global Red List of threatened species. Using our experience in North America and South Africa, we will discuss the implications of classification scale and the results of status assessment using the RLE. We will provide a brief background on ecosystem status assessment and then use each case example to illustrate the implications of classification scale on assessment results. Scientific foundations for the Red List of Ecosystems were based on a series of global expert forums and publications. While intended to work in parallel to the Red List of Threatened Species, the process addresses ecosystem types. Perhaps most fundamentally, we acknowledge that while species go extinct, and hence the Red List of Threatened Species aims to gauge the risk of extinction, ecosystems do not go extinct, but rather transform into novel ecosystems. Therefore, the aim of the RLE is to assess the risk of range-wide ecosystem collapse. That is, the transformation of identity, loss of defining features, and replacement by novel or cultural ecosystems. The RLE provides a framework for component analyses addressing 4 criteria, 2 based on trends in ecosystem area or susceptibility due to spatially explicit threats, and the other 2 based on trends in ecosystem processes, i.e. condition, function, or integrity from both abiotic and biotic perspectives. But the first step in the process is to define ecosystems to be assessed, and this is where classification approach and scale come into play. NatureServe uses a vegetation-based hierarchy, which forms the basis for the International Vegetation Classification, or IVC, and it provides a mechanism to classify and describe classification units at multiple levels of thematic detail. The example shown here occurs in the Canadian prairies. As you go down in the hierarchy, each classification unit describes a more specific unit that applies to increasingly localized areas. Multiple alliances make up the Northern Great Plains Rough Fescue Prairie group, and many associations make up each of those alliances. In parallel, the IUCN has proposed a functionally based classification hierarchy, and terrestrial components of that classification can be related to our vegetation-based hierarchy as a parallel structure for organizing the red listing. In principle, units from multiple levels of any hierarchy can be red listed. For our current work in temperate North America, we focus on level 5, where the NatureServe ecological systems form the basis for analysis. These classification units are approximately equivalent to the group or alliance level of the vegetation hierarchy. Working within the terrestrial realm of this IUCN framework, there are 34 IUCN functional groups in temperate and tropical North America. Again, these roughly approximate the formation level of the IVC. This map depicts approximately historic location of these 34 types in the region. And our terrestrial ecological systems roughly approximate group and alliance levels of the vegetation hierarchy. Again, these are our primary units of assessment in North America. So we have 34 IUCN L3 ecosystem functional groups, 150 vegetation macro groups, or IUCN level 4, and 640 ecological systems, or approximately IUCN level 5. So this sets the stage for our North America Red List assessment. Now let's turn to South Africa. Situated on the southern tip of the continent, South Africa has a land mass of just over 1.2 million square kilometers, or double the size of Texas. It is home to an extremely wide range of bioclimatic regimes, typical of southern hemisphere continents. In arid western regions, they are characterized by deserts and cold ocean. Winter rainfall regions, the world-renowned fynbos biome, occur in the southwest. There's an elevated interior plateau and dry temperate shrublands, as well as more mesic grasslands in the interior. The eastern and northern regions have subtropical climate that is typical of sub-Saharan Africa. Forests are naturally fragmented and scattered in an arc from the south coast to the northeast regions, restricted to mesic localities. Being a relatively temperate tip of a tropical continent means that more than 85% of the vegetation types are endemic to South Africa, mirroring the extremely high plant species endemism described for the country. Like the USA, there's also a long tradition of vegetation mapping in South Africa, here with 458 units described and delineated by Musina and Rutherford in 2006. These correspond approximately to the IUCN level 6 units. Crosswalk of the South African vegetation types to IUCN Level 3 functional groups was undertaken by Sanby's VegMap team. The majority of the types nested within one IUCN Level 3 group, but there were a number of South Africa vegetation types which corresponded to 2 or more L3 types. Coastal areas and thicket vegetation presented some challenges. Overall, the 458 South Africa veg types could be assigned to 14 L3 groups, clearly illustrating the rainfall gradient of the interior plateau. For purposes of this study, the South African veg types were also grouped together at an intermediate level for IUCN, approximately level 5. This resulted in 73 of what we call major functional vegetation types in South Africa. There's no current equivalent hierarchical level described in Musina and Rutherford in 2006, but it is common for South African scientists to group the types in this way for various studies, including ecosystem accounting pilots and ecosystem service assessments. So for application to red listing processes, we focus here on level 5 and level 6 types, which are typical for continental or national scale assessments using red listing, but we put them in the context of the broader level 3 IUCN types. In summary, for South Africa, you can see that these units are relative to both the IUCN and IVC hierarchies. We have 14 of the IUCN level 3 types, 73 that approximate IUCN level 5, and 458 units that are about the IUCN level 6 types. Jumping back to the red listing process for a moment, this table illustrates an example of scoring several RLE criteria for this big sagebrush shrubland in Western North America. Not yet accounting for climate change, this type approaches the thresholds of vulnerable status, but will be scored for now as near threatened. As with red listing for species, the worst score for any one of the criteria tends to translate into the overall score. Our initial results from North America show distinct patterns with extensive areas historically dominated by temperate grasslands, wetlands, and eastern forests converted for agriculture, resulting in a large proportions of types scoring within the range of critically endangered, endangered, or vulnerable under IUCN criteria. Here we show these results mapped on historical extent as well as the current footprint. About 22% of the current land area here includes ecosystem scoring as critically endangered, endangered, or vulnerable. Taking a subset of the 640 North American ecosystems assessed, these include about 52% of all types. Were taken from the most diverse ecosystem functional groups, that is L3 of the IUCN framework, and then structured in terms of L4s or macro groups. This provides an indication of the relationship among these classification levels. Note the high variation in red list scores within each macro group, that's L4, and certainly within individual L3 functional groups. Each of these macro groups encompass a wide range of types, some occurring across large to small area in locations where threats stemming from land use vary from very intense to very limited. See one extreme in particular, temperate subhuman grasslands that embody such a range from critically endangered tallgrass prairies to least concerned types such as montane grasslands and shrublands. Therefore, you could see the broader the classification concept, the more likely one is to mask underlying patterns of more extreme threat expressed in finer grained classification concepts. This map depicts South Africa's official national red list at IUCN level 6. The assessment used in the historic and ongoing habitat loss criteria and the limited extent criteria, all based on land cover change data sets. The ecosystem condition or health criteria were only applied to those regions for which data was available, a shortcoming we hope to fix because it results in an underestimation of risk to ecosystems in the vast interior rangelands. The assessment clearly shows the high level of habitat loss in the Fynbos lowlands in the southwest. These are the wheatlands and winelands. Most of the remaining habitat there is listed as critically endangered. The mesic grasslands where maize and soya crops, as well as coal and gold mines abound, result in many vulnerable and endangered types in the interior. The eastern coastal areas, like KwaZulu-Natal, have very high rural population densities and rampant coastal residential and agricultural expansion. This entire region is threatened. When the assessment is undertaken at the 73 level 5 units compared to the 458 level 6 units, type scores also lump from critically endangered or endangered to vulnerable. This is expected since the units of assessment have expanded in extent and encompass a wider range of land uses and intensities. The assessment at level 5 would certainly be useful for continental scale assessment, but in our case, undertaking the RLE at level 6 provides information better suited to national scale land uses. 103 of the 458, or 23% of South African vegetation types, are considered threatened. That is, they're vulnerable, endangered, or critically endangered. The majority of these types fall within the Cape Floristic region, or the fynbos. Mesic grasslands of South Africa are also highly threatened. Yet, if the RLE were implemented above level 5, these unique and highly impacted regions might not be considered at risk. A continental or global RLE that did not reflect the fynbos as at risk would be questionable. In applying an at-risk criteria to standardized classifications, we provide one important focus for governments and civil society to prioritize conservation efforts. However, users of ecosystem risk assessment methods should be aware of the implications of classification approach and thematic detail in their outcomes. Using these two examples, we demonstrate a clear effect of classification scale on assessment results. Types assessed above IUCN level 5 would clearly mask underlying status patterns that manifest themselves when finer grained concepts are used. Using the IUCN global typology, the level 5 and level 6 define the sweet spots for assessment that, at least considering conditions in North America and South Africa, strike a balance between identifying important patterns in status with available data. Thank you.